Everyone. Hello, everybody, and thank you so much for showing up today. My name is Milushin, and I've recently been employed as the staff training lead at Project Empower, but that's already too much about me. Let's get to what you're looking at. In case you haven't figured it out yet, today I'm going to be discussing microcontrollers, deauthenticators, and this crazy new thing you probably haven't heard about yet, artificial intelligence. This presentation will go in depth into Wi-Fi deauthenticators following my project of actually making one as seen right here, and how AI tied into this project. So let's get started with what a deauther even is in the first place. Well, to understand what a deauther is, we need to first understand how it is that routers communicate. And to do so, they use what are called data packets, which there's a great picture of right below right there, which transport these frames, such as a deauthentication frame as the payload right there, which is simply a request to disconnect. Deauthenticators exploit this frame by spoofing an IP address and sending packets containing deauthentication frames, which in turn repeatedly ask to disconnect from the router while pretending to be the device that's connected to the router, which means that basically this disconnects all the devices that are connected to a router. Because of this, from the user standpoint, it looks like their internet connection just suddenly stopped working, as it tends to do so. But why is this beneficial to hackers? Simply disconnecting a user might seem like just a harmless prank to play, but this can be exploited much further, as discussed later. First, though, why not check out how it works? So, right here is the deauthor. Let me switch over to my camera. Oh, I didn't switch my camera. So, let me switch the camera. There we go. And right here's the deauthor, and we can see that I can scan all the networks around, which shouldn't take longer than a couple seconds. There we go. So I overestimated the speed, but here it is, and it is all done. And now we can select a network. So let's go to APs and go to my network, and then go back and go to attack. Now we can launch a deauthentication attack, but this isn't going to work because my router supports both 5G and 2.4 gigahertz, while this only runs on 2.4 gigahertz. But let's stop that attack anyways and go back to, the rest of the presentation. So now you might be asking, if you were there and you saw the actual thing go off, wait a minute, isn't that just a dumb Wi-Fi jammer? Well, Wi-Fi jammers are still cool, I mean, look at how sick that one right there looks. And so does mine. Jokes aside, though, the difference between the deauthor and a simple jammer conveniently makes one legal, or at least legal-ish, and the other illegal. And that difference is that Wi-Fi jammers indiscriminately create noise across a range of frequencies, blocking all communication within their radius. This lack of selectivity can lead to serious consequences like, for example, preventing emergency calls, making them illegal in many places, yes, including the United States. But besides that, jammers also look awesome, like I just said. I mean, look at that. It's like a forest of jamming. But once again, so does this. Wi-Fi deauthors, however, are more precise in their approach. They allow you to target a specific network or even a single device by, once again, spoofing that device or router's MAC address or physical address, and then sending out deauthentication frames from that device, but not really. But there is still an obvious catch. While owning a deauthenticator might be legal, its use is restricted, and you should only use it on networks and devices you own, and always with caution. And of course, here's your little quick obligatory warning that unauthorized use is not only unethical, but also illegal. Moving on, though, why would hackers deauthenticate? While it may seem trivial at first, there are indeed a multitude of reasons for hackers to launch a deauthentication attack. And one example of one could be creating evil twin access points or networks that appear as if they're the same one that you are on. Another great example is a WPA pass cracking attack, which utilizes the handshake occurring when the user is reconnecting, as well as many different exploits that can be used through Wi-Fi Fisher, its logo seen up here. And not only hackers have utilized deauthenticator attacks, In fact, several hotels had actually gotten themselves into legal trouble with the FCC for using Wi-Fi deauthenticators in order to force users off of their free network and pay for their premium Wi-Fi. Hilton and Marriott. Sorry, that's something in my throat there. But anyways, let's check out one of these reasons, which is WPA pass cracking. But before we dive deep into WPA pass cracking, let's set the stage with a bit of background. In the vast realm of wireless security, WPA stands as a standard, so it's essential to understand its roots and variations. And as a side note, by WPA, I do mean its entire nomenclature. So let's start out with WPA1, usually just referred to as WPA, which stands for Wi-Fi Protected Access. WPA was a badly needed standard patch rolled out to shield networks worldwide from the vulnerabilities of its predecessor, WEP, and there were a lot of those vulnerabilities. While there are newer iterations like WPA2 and WPA3, each with their own set of cryptographic enhancements, they all do share a common DNA, if you will. And of course, they all have their own Achilles heels, especially when it comes to pass cracking, though the methods may vary slightly. But for our deep dive today, we're going old school, focusing on the classic, the original, plain old WPA. This protocol, despite its age, still finds its place in many networks, and between you and me, our home router used just that until very recently. But anyways, now that we know that our discussion is still indeed relevant, strap in and let's get cracking. And yes, the pun was very much intended. WPA password cracking typically starts by capturing a four-way handshake between a user and an access point. And just to quickly clarify for those that don't know, this handshake is simply the process of a user connecting to an access point or a network. And while this can be achieved by patiently waiting for a user to connect, there is a more fun approach to this, deauthenticating all users from the network with, I don't know, maybe a barely working, shoddily soldered deauther you made in 3 days, which is held together with a literal hair tie. And now that you have a bunch of users reconnecting, initiating the handshake. See where this is headed? Once the handshake is in play, CLI tools like AeroDumpNG or even more sophisticated packet analyzers like Wireshark, for example, come into the picture. These tools allow us to capture the handshake, which is then saved as a .cap file. Oh, and a quick fun fact, the .cap extension actually stands for capture packet. But here's where the magic happens. The actual cracking process involves generating a series of PMKs, or pairwise master keys, which are derived from a combination of a passphrase and the SSID, or the network's name. So using a word list, we can generate a bunch of these potential PMKs and then compare them against the captured handshake. When a match is found, voila, we've identified the passphrase. It's kind of like brute forcing, but with the added advantage that you don't need to be in the router's proximity or even online, really. To exemplify why this would be used, say you have a crappy laptop with Wireshark and you manage to snag one of those PMKs from a router, but don't have the ability to crack the hash locally. From here on, you can simply send it to a hash cracking rig somewhere else, which is a machine specifically built to, well, crack hashes. And after a bit of cracking, you'll get your password. But this is starting to get incredibly wordy, so let me just recap this as a quick order of events. The user provides a passphrase to connect to the network, and then the passphrase and the SSID of the network are hashed together using a hashing function, in this case pbkdf2, which is unimportant, but this hashing function then hashes the passphrase and SSID combination 4,096 times to produce a 256-bit PMK. This means that if we hash together the correct password and SSID, or network name, then we'll get an identical PMK to the one that was captured in the .cap file. And we can see this right here with the input of pass123 and 1+, which is my router name, having the output of this PMK. So from then on, we can use a word list to make a bunch of these PMKs, as seen here in the bottom, with pass1 and 1+, resulting in this key, pass2 and 1+, resulting in that one, and so on, until we get to the combination of pass123 and 1+, which would result in an identical key. However, there is a catch. This process can be time-consuming, and it could take anywhere from a few minutes to several hours, all depending on your, the complexity of the passphrase, the size of the word list, and your hardware. While it would be an easy way to lengthen my presentation time, I don't think it would be the most riveting spectacle for this esteemed audience. So let's get moving on with something else that's also fun. Wi-Fi Fisher. Wi-Fi Fisher is a vast, streamlined framework of many, many, many different tools and techniques, which deserve a presentation of their own. So I will try to narrow it down only to the tools that are directly applicable here, which are its phishing elements. Not only is Wi-Fi Fisher capable of creating evil twin access points, as discussed earlier, but it also has some built-in fake captive portals for these twin access points, with some generic excuses such as Wi-Fi logins, OAuth logins, etc. And in case you are unfamiliar with captive portals, these are the web pages that are brought up when you connect to, say, Starbucks Wi-Fi, and then it asks you for your name, last name, email, postal code, social security number, the normal stuff. But all we need to know about these captive portals really is that in our case, they're simply asking for a password to the Wi-Fi, again. And once this user inputs the password into the captive portal, it's game over. It gets redirected back to you, and they keep surfing the web like nothing even happened. You can now use the same password, and in turn, you've successfully completed an evil twin access point attack. Enjoy your access to the premium Wi-Fi. Oh, and no, please don't attack networks you don't own. But again, there's so much more to Wi-Fi Fisher, and this is just a really specific use case of it. And I highly recommend you take some time to look into it yourself if you are interested. And as a side note, thank you so much to Wikipedia for this incredible graphic demonstrating an evil twin access point attack. And let me just zoom in so you can all truly enjoy it. Just look at how beautiful that is. The jagged lines, the straight arrow. I mean, it's so beautiful, and the questionable looking router. But moving on to the elephant in the room, AI and the development of, well, this. The process to create this ESP-based deauther was, of course, long and convoluted, given I had almost no experience with both I had plenty of experience with both microcontrollers and deauthentication attacks. I was a professional in the field, but I will admit that AI such as ChatGPT greatly helped with this, and I don't think I could have done this project with it. No, I could have done it without it, definitely, for sure. But, the great thing with it is that it is perfect for asking those simple but niche questions, as well as cryptic errors that you just can't find in Stack Overflow. For example, earlier in the flashing process, I received cryptic output, which, funnily enough, expressed my thoughts quite accurately, with the output of question, pipe, question, exclamation point, question, and so on. And this would have most likely taken me hours to figure out pre-GPT, but with ChatGPT, it instantly suggested that the improper baud rate may be the issue. And for those that are curious, baud rate is just the rate that information is being sent from the deauthor back to my computer, or just any microcontroller, really. And again, it is important, though, to consider what the downsides of these language learning models are, which conveniently brings us to utilizing AI, the bad. If you've ever worked in any form of customer relations, be it through tech support or even working for someone like a manager, you'll come to know that the last person to know what they want is, in fact, the customer. And during this project, I was that customer. A good example of this could be the countless frustrating hours I spent with some kind of watchdog error, which caused the single board computer to restart every few seconds. This error was, stupidly enough, due to the fact that I was persistent that my board was a generic ESP8266 and not a Node MCU board. So note to anybody that is, that won these and is going to try the same thing, it's a Node MCU board. Save yourself the time. This unfortunate lapse in judgment caused me and poor ChatGPT to spend a solid day trying to get around this watchdog, when in reality the problem was that the code was just getting compiled for a different board, and I didn't need to do that. But moving on to utilizing the AI, the ugly. Although AI can be utilized to an extent in any field, it is important to consider its limitations. One of the biggest things to consider is how language learning models such as ChatGPT can't truly comprehend things and are catered towards simply coming up with plausible sounding answers based on data scraped off of the web and exemplifying that data. Although this is greatly improved on in more modern models, such as GPT 3.5 and 4, it does still show its prevalence, especially so if you've ever worked with the more outdated models through their API, or if you ask it if 450 is 90% of 500. However, the biggest issue with AI is its lack of privacy. While for small personal projects like this one, it might not be the biggest issue, upscaling this to a company's cybersecurity rules could lead to some very interesting issues, as demonstrated in the Android ChatGPT data leak, where confidential source code was provided to ChatGPT 3 separate times in the span of 1 month. And when consulted about their AI retraining data to further train itself, they answered stating, "Your conversations may be reviewed by our AI trainers to improve our systems. So, don't use it for confidential data," especially if your company has introduced one of these many new tools to avoid this, as seen right here. But you might have noticed that now we're moving on to, okay, so I didn't say any of this. I'm just going to restart this slide. Defending against them. Does AI come into play? You might have noticed that I had to use my phone hotspot for this exploit because I could limit it to 2.4 gigahertz. So you might be inclined to just get a 5 gigahertz router, right? Well, a Wi-Fi upgrade is always nice, but with all things tech, of course it can't be that simple, and it isn't. My deauther is only limited to 2.4 gigahertz due to the Wi-Fi chip it uses, and at this point there are several deauther softwares that can run natively on any computer, at least assuming the existence of a wireless adapter capable of monitoring mode as well as packet injection, which, as a side note, isn't typical on an ordinary network card, but you can still find it on Amazon. And here comes the AI. Some of the ways AI and machine learning algorithms could defend against deauth attacks are through pattern seeking and analyzing normal packet behavior of devices in order to single out rogue devices or fake access points with device profiling. But it's not even guaranteed if this or how this AI IDPS, or artificial intelligence intrusion detection prevention system, would even work. Which brings us to the much simpler application of AI and ChatGPT, which is simply asking it how to update your router to the 802.11w standard, which protects against deauth attacks by using protected management frames, which encrypt all frames sent to and from the router. And this greatly defends against frame spoofing, such as deauthentication frame spoofing, which is exactly what this uses, and in turn defends against that. So, the end, or at least for now. Thank you so much to everybody here today for letting me blabble on to you. Oh, I can't see. I don't got any notes for this. So if anybody has any questions, please feel free to ask absolutely anything, and I will try my best to answer. And if not, ChatGPT will. Any questions can go to skepticseptic1@gmail.com. And any and all questions at all, whether that be to the project or to the process of making the project or the PowerPoint, the presentation, any questions at all are welcome. And if you are curious, I do have a short little quiz afterwards. And let's start off with, what does WPA stand for? If you want to go through it, just feel free to pause, because the answer is Wi-Fi protected access. Moving on to, which type of attack involves creating a network that appears as if it's the same one you were on? And the answer to this one is evil twin access point attack. And then, what does PMK stand for? The answer to this one is pairwise master key. And now for a bonus question. What does .cap mean? The answer to this one is capture packet. As a legal disclaimer, anybody that receives the ESP8266 just normal standard stuff, such as side effects of using the ESP8266s may include but are not limited to seizure, death, rapid combustion, spontaneous human combustion, unspontaneous human combustion, the normal stuff. Point is, I'm not liable for that. Moving on. As a one last thing, I just wanted to thank Project Empower. And if you did somehow manage to enjoy listening to me speak about this stuff and have a kid or maybe a relative that you want to get into the field, there's a great opportunity to do so. Boot them off towards Project Empower at Charlotte, which is an awesome volunteer group aiming to address the digital divide through coding classes for youth in grades 3 to 8 at Charlotte at no cost. And the coolest part is that all the teachers there are fellow tech-aspiring teenagers in grades 9 through 12, just like yours truly. And if you would like to support them in any way, please reach out at projectempowerclt@gmail.com, because they are in need of many basic supplies as listed in the Amazon wish list to the right, since most of their kids do come from underprivileged backgrounds. Thank you so much, and give yourselves a round of applause. Once again, I just want to say thank you very much to each and every one of you here, and I really do hope you learned something new from this. I know I did. And if there is anyone among you that would like to follow me on LinkedIn, seeing as I'm just such a popular figure in the cybersecurity world, this QR code right here will take you there. Thank you so much.